over x minus 1 times x squared plus 1, where x is between 2 and 5. It says use trapezium rule with 3 equal intervals to estimate the area bounded by f between the lines y equals 0, x equals 2, and x being 5. So pretty much we're integrating f of x from 2 to 5. So this is what we're finding. We're finding the integral from 2 to 5 of f of x. That's what we're finding, but we're going to be using trapezium rule. Using trapezium rule, the integral from 2 to 5 of f of x, trapezium rule, it's going to be h over 2 into y naught, where y naught is the last y value, y naught plus yn plus 2 times the other y values, plus 2 times your y1, da 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 da. So that's the formula that we use for trapezium rule. So let's go ahead and do this using trapezium rule. What I like to do first is, of course, work out h. H is going to be b minus a, which is 5 minus 2, which is 3, over n. N is 3, so h is 3 over 3, which is 1. So next thing I like to do is create my table. I like to create my table. My table just gives me my values of x and y for the different ordinates. So this is x, and this is my y values. When x is, I need to go from, that's going to be from 2, then I go 3, then I go 4, then I go 5. All right, that's what I need to do. Plug in 2. When x is 2, what would I get up here? 2 squared plus 2 times 2 plus 3, that's 11, divided by 2 minus 1 times 2 squared plus 1, and 2 squared is 4, 4 plus 1 is 5. So right here I'm getting y as 2.2. That's for when x is 2. When x is 3, what will I get? I'll get 3 squared plus 2 times 3 plus 3, which is 18, divided by, that's 3 minus 1, times 3 squared is 9, plus 1 is 10. I get 0.9. Then I put in 4, I get 4 squared, plus 2 times 4, plus 3, it's 27, divided by 3 times 7, 4 squared is 16, plus 1 is 17. I get 0.53. I get 0.53. Then I plug in 5, and I'm getting 5 squared plus 2 times 5 plus 3 is 38, divided by 4 times 26, and I get 0.365. 0.37. And so using trapezium rule to evaluate the area is going to be equal to h over 2. H is 1, so it's 1 over 2 into y naught. Y naught is the first y value of 2.2 plus yn, which is plus 0.37, plus 2 times 0.9 plus 0.53. So 0.9 plus 0.53. So when I work this out, that will give me the area. So working this out, I'm going to get, let's put all of this in our calculator. 2.2 plus 0.37 plus 2 times 0.9 plus 0.53 divided by 2. and I get 2.72. So that's the area. I get 2.72. That's what I'm getting using trapezium rule. Nice. Now it says, using partial fraction, show that f of x is 3 over x minus 1 minus 2x over x squared plus 1. So we need to separate it using partial fractions. So let's look back what f of x was. F of x is x squared plus 2x plus 3. So we have x squared plus 2x plus 3. That's being divided by x minus 1 times x squared plus 1. So now we're doing this division now. And so what we're going to get is, this is going to be, well, it's going to be a constant a over x minus 1. So it's a constant a over x minus 1 plus, it's going to be bx plus c over x squared plus 1. So now all you have to do is find the common LCM. The common LCM is going to be, of course, x minus 1 times x squared plus 1. And so this into this leaves x squared plus 1. So it's going to be a times x squared plus 1, which is ax squared plus a. And then this into this leaves x minus 1. So it's going to be bx plus c times x minus 1. And remember, it's equal to this. All right. So now, whenever the denominators are the same, we can just equate their numerators. So this implies that equating their numerators, what they're basically saying then is x squared plus 2x plus 3, x squared plus 2x plus 3 is equal to ax squared plus a. Now bx times x is bx squared, so it becomes plus bx squared. Bx squared, now bx times minus 1 is minus bx. Then c times x is plus cx. Then c times minus 1 is minus c. And so that's what we have. So all we have to do now is equate coefficients. Equating coefficients, we have x squared, and we have ax squared and bx squared here. So what that is telling us is 1 is equal to a plus b. Equating x terms, we say 2x. 2x is equal to minus bx plus cx. So we can write it as 2 is equal to minus b plus c. And then we have 3 is equal to a minus c. A minus c. All right, nice and easy. From the first and the third equation, I'm going to subtract them equation 3 minus equation 1. That will give me 3 minus 1 is 2. A minus A gone, and so I left back with minus C minus B. So 2 is equal to minus C minus B. But I also have 2 is equal to minus B plus C. Nice. So that means if I add these two equations, what's going to happen? 2 plus 2 is 4. And so 4 is equal to minus C plus minus C gone. And so 4 is equal to minus 2B. And so if 4 is equal to minus 2B, then that means that B is equal to negative 2. If B is equal to negative 2, I can substitute B being negative 2 in the first equation. And so that means if I have negative 2 here, I can bring over negative 2 to get positive 3. And so if B is negative 2, then A is 3. If A is 3, then that means 3 minus C is 3. And so C must be 0. So C must be 0. So what does all that mean? That means that in conclusion, if you replace this now with A is just 3. I'm going to replace A up here now. A is just 3. A is 3. All right, nice. B is now minus 2. And C is 0. So we can replace those and say C is of course now 0. B is minus 2. Now if B is minus 2, instead of putting minus 2x in the numerator, the plus and a minus just give you a minus anyway. So we can just replace this plus right here with a minus. And then we can just ignore the plus 0. The plus 0 doesn't change anything. So that's what we do to show that. All right, so that's done. So write shown. All right, or you can write proven. That takes care of that. It says, hence, evaluate the integral from 2 to 5 of f of x. Since it says hence, instead of using this, we're going to use this. All right. So what we're then going to say is, since it says hence, we're going to say, so the integral from 2 to 5 of f of x dx, integral from 2 to 5 of f of x dx, that's going to be equal to, using the hence, it's going to be the integral from 2 to 5 of, the integral from 2 to 5 of 3 over x minus 1 minus the integral from 2 to 5 of 2x over x squared plus 1. Now I left off my dx, but don't ever do that. Now integrating this, you're going to get integral of 3 over ln x minus 1. If you factor out the 3, you're going to get 3 times ln of x minus 1. So it's 3 times ln x minus 1. And you're integrating that from 2 to 5. Minus, now the integral of this, the differential of x squared is 2x. And so it's just going to be minus ln x squared plus 1 from 2 to 5. Integrating that from 2 to 5. So now we're just going to plug in those now. So it's going to be 3 times, plugging in 5, it's going to be ln 4, 3 times ln 4 minus ln 1, and ln 1 is 0, so it's 3 ln 4 minus, plugging in this now, we're going to get 5 squared plus 1 is 26, so that's ln 26 minus ln 5. Put all of this in a calculator. 3 ln 4 is just ln 4 cube. You put in a calculator ln 4 cube minus ln 26 plus ln 5. Nice and easy, soft. So you work this out and you're gonna get ln 4 cube, 4 cube. So ln 4 cube, which is 64, minus ln 26 plus ln 5, that's 2.51. Nice and easy, soft. That takes care of question 2, and now we will go to module 2. Nice. 3. Question 3 is module 2, and module 2, it says, a sequence is defined by the recurrence relation un plus 1 is equal to un minus 1 plus x times un prime, where u1 is 1 and u2 equal x, and un prime is the derivative of un. For example, u3 is u2 plus 1, which is u1 plus x times un prime, which is equal to 1 plus x. So in this case, it says given that u8 is 13 plus x and u10 is 34x plus 1, find u9 prime. All right, so this is the formula. I always start with the formula. So I start in the formula that un plus 1, and they say that's equal to un minus 1 plus x times un prime. So we need un prime, and we need u9 prime, so we need to let n equal 9. So we're gonna let n equal 9. Let n be equal to the magic number of 9. If n is equal to 9, we're gonna get u of 9 plus 1, and that's gonna be u10. And so we're gonna get u10 is equal to 9 minus 1 is 8, and so u10 is equal to u8 plus x times u9 prime. And so now we need u9 prime to be the subject. So I'm going to subtract u8 and then divide by x. So what I'm saying is u9 prime, when I make this the subject, it is equal to u10 minus u8 over x. That's u9 prime. So let's go ahead and do that. Looking at it, u8 is 13 plus 1, 13x plus 1, and u10 is 34x plus 1. So u9 prime will be equal to u10, which is 34x plus 1, minus u8, which is 13x plus 1, and that's being divided by x. And that's u9 prime. right? So now that that is U9 prime, we can go ahead and continue. And what we're going to get is U9 prime is equal to 34x minus 13x, which is 19x. And so we have 19x, 1 minus 1 is 19x, and 19x over 9 is just 19. So 34 minus 13. Oh, I made an addition error. 34x minus 13x is 21. So U9 prime is 21. My apologies. That's 21. It's going to be 21x divided by x. And 21x over 21x is 21. Nice and easy. So that takes care of that. Very easy question. Well, let's look at this now. It says the nth partial sum of a series is given by Sn, which is the sum from 1 to n of r times r minus 1. Show that Sn is equal to n times n squared minus 1 over 3. There's two ways to do it. You can use method of differences, or you can use the formula. All right. So let's just use the formula. Using the formula method, we're going to have that Sn is equal to the sum from r equal 1 to n of, instead of saying r times r minus 1, we're going to write it as the sum of r squared minus r. And then we know using summation laws, we can rewrite this as the sum from 1 to n of r squared minus the sum from 1 to n of r. Now the sum from 1 to n of r squared is given by a formula, and that formula is 1 over 6n, 1 over 6n, 1 over 6n times n plus 1 times 2n plus 1. That's the sum from r equal 1 to n of r squared. It's 1 over 6n into n plus 1 times 2n plus 1. Then it's going to be minus the sum from 1 to n of r squared, which is a half n into n plus 1. That's a half n into n plus 1. Cool. All right. Now that we have this, what can we do? Well, what we can do is, well, we can factor out, let me see. We can factor out, I'm going to change this as a half. I'm going to rewrite a half as 3 divided by 6, just for now. It's going to make it easy to factorize. I'm going to write it as 3 over 6. So that allows me to factor out a half, well, 1 over 6n times n plus 1. And when I factor that out, I'm going to be left back with, factoring out that, I'm left back with 2n plus 1, 2n plus 1. Yep. And I factored out 1 over 6n into n plus 1, so I'm left back with 2n plus 1 minus 3. And so what I'm getting then is, this becomes 1 over 6n times n plus 1 times 2n minus 2. And so I can factor out the 2. And factoring out the 2, I'm going to get, factoring out this 2, you get 2 over 6 of n times n plus 1 times n minus 1. All I did was factor out the 2 out of 2n minus 6. Factoring out that 2, now 2 over 6 is just 1 over 3. So you get 1 over 3n. Then n plus 1 times n minus 1 is n squared minus 1. Nice and easy, soft. And that takes care of this question. All right, nice and easy, soft. So that takes care of this question and we'll finish. Now let's go here. It says hence or otherwise evaluate the sum from r equal 10 to 20 of r into r minus 1. Now, notice that the formula only applies when you're summing from 1 to n. So what we have to just write down first and foremost is that the sum from 10 to 20 in general of this right here, all right? The sum from 10 to 20 is just going to equal to the sum from 1 to 20 minus the sum from 1 to 11. All right? That's it. That's all. And so the sum from 10 to 20 is going to be equal to, using the formula is going to be, here's the formula, 1 over 3n into n squared minus 1. So it's going to be 1 over 3n. In this case, n is 20. So it's 1 over 3n, which is 20 times n squared minus 1. That's the formula, n squared minus 1. N squared is 20 squared minus 1. And then we're going to subtract 1 over 3 into n times n squared minus 1. All right, nice and easy, soft. So let's continue now. So let's work this question out. So that's going to be 1 over 3 times 20 times 20 squared is 400 minus 1. This part works out to be 2,660 minus, let's work out this part now. You have 1 over 3 times 11 squared, which is 121 minus 1. That part works out to be 440. And so you take the difference and that will be the final result. Nice and easy, soft. 2,660 minus 440, which is 2,220. 2,220. Nice and easy, soft. And that's that. All right, lovely. Now, part C says, given that NPR is n factorial over n minus r factorial, show that 2rpr of npr over 2r factorial is equal to n choose r. Before I do this question, let's just write down what n choose r is. We need to recall that n choose r is equal to n factorial over n choose r all right, so I don't know why the screen got pitch blank. All right, so we don't know what just happened, but let's continue. So what we're trying to show right now is we're trying to show that this is equal to this, but we know that n choose r, as we said, n choose r, that's just n factorial over, that's n factorial over r factorial times n minus r factorial. This is n choose r. All right, so that's what we're going to try to let that prove to be. So let's do that. So we're going to start with our left-hand side. Let's zoom in a little bit. So our left-hand side, we're starting with the left-hand side being 2r. So it's 2r permutes r multiplied by n permutes r over 2 factorial, 2r factorial. Okay, so what we do know is that this is going to be equivalent to, now 2r permute r, we're replacing n with 2r, so it's going to be 2r factorial divided by n minus r, so it's going to be 2r minus r. 2r minus r is r factorial times n permute r is going to be n factorial over n minus r factorial, and it is being divided by, 2r factorial. Since it's being divided by 2r factorial, we can rewrite it as being multiplied by 1 over 2r factorial. 1 over 2r factorial. That's what division means. All right, and so in reality, this 2r factorial will cancel this 2r factorial. And so what we're left with is n factorial over r factorial times n minus r factorial. Nice and easy, soft. So that's what we're left with. All right, and remember, this is actually n choose r. So it is proven. All right, some people might want to write it in this form. It is indeed n choose r. All right, so soft. This question was too easy, and so you're right, soft. Nice. Now let's look at this part of the question. It says, determine the coefficient of, determine x cubed in this binomial expansion. So to determine the coefficient of x cubed in this binomial expansion, well, you need to determine the coefficient of x cubed. And so the coefficient of x cubed, it is going to be, all right, so let's do that. For the term with x cubed is going to be, we're choosing 2 of 5, and it's going to be 3x cubed times 2 square. All right, this is for the x cubed term. So if you want to write it down right here, so tell them that this is finding out whatever is the x cubed term. All right, so that's the x cubed term. So what we're getting is, if you're to work this out, 5 choose 2, you're going to get 5 choose 2 is 10. 5 choose 2 is 10. Then we have 3x cubed. 3 cubed is 27. So we'll get 27x cubed. And then after we get 27x cubed, 2 square is 4. So then 4 times 10 is 40. And so let's work out what is 10 times 27 times 4. All right, so 10 times 27 times 4 is 1080. So we get 1080 x cubed. 1080 x cubed. Now remember what the question asks. You can't stop here. The question asks for the coefficient of x cubed. And so the coefficient of x cubed, is 1080. That's our conclusion. The coefficient of x cubed. Well, the coefficient of x cubed term. Let's rephrase it. Coefficient of the x cubed term is 1080. Nice and easy. So that completes question number 3. Moving right along, and we go to question 4. Question 4 says the function f is defined as f of x is the 6th root of 4x squared plus 4x plus 1, where x is between 1 and minus 1. Show that f of x is 1 plus 2x to the 1/3. To attempt this question, we have to start with this. So first we have to start by saying, well, they gave us that f of x. They gave us that f of x is equal to, let's write it down. F of x is equal to 4x squared plus 4x plus 1. F of x is 4x squared plus 4x plus 1. All right, and we want the 6th root of that. And so that what that works out to be is 4x squared plus 4x plus 1. This can be rewritten as 2x plus 1 all square. That's 4x plus 1 all square. 2x plus 1 all square. Square rooted. Well, not square rooted to the 6th root. Now remember, by laws of indices, we can addition, first and foremost, addition is commutative. So we can reorder that as 1 plus 2x being squared. And if you have 1 plus 2x being squared, and then the 6th root can be written as raised to the 1/6 power. We can rewrite it like that. But then, by laws of indices, this is really 1 plus 2x to the 1/3 power, because it becomes 2 times 1/6 by laws of indices. So we get 1 plus 2x raised to the 1/3. Nice and easy, soft. And that's that. That's how we get f of x. So that's question 4, part A, I. Nice and easy. All right. So let's look at this. So it says now, the series expansion of 1 plus x to the k is given as 1 plus kx plus k times k minus 2x squared over 2 plus k times k minus 2x cubed over 3 plus k times k minus 1 times k minus 3x to the 4 over 4 factorial. And it says determine the series expansion of f up to and including determine x to the 4. So let's do this question. To do this now, we want the series expansion up to determine x to the 4. But in this case, all we're going to do is replace x with 2x and k with 1/3. That's all we're going to do. All right. So all we're going to rewrite then and say, determine the series expansion for f of x. So in this case, f of x is going to be equal to, it's equal to 1 plus kx. Kx is going to be, k is 1/3, x is 2x, So it's 1 over 3 times 2x plus k times k minus 1. K is 1 over 3. And so k minus 1 is going to be 1 over 3 minus 1. So you work that out. 1 over 3 minus 1. That's minus 2 over 3. It's really sad that I just used the calculator to do that. That's really sad. Times x squared. But x squared is really 2x squared. And it's all being divided by 2 factorial. 2 factorial is 2 plus, that's going to be k times k minus 1 times k minus 2, which is going to be 1 over 3 times 1 minus 1 k. 1 over 3 minus 1 is minus 2 over 3. And then minus 1 again is going to be minus 5 over 3. X cubed over 3 factorial. And 3 factorial is going to be 6 plus k times k minus 1 times k minus 2 times k minus 3. That's going to be 1 over 3 times, that's going to be minus 2 over 3 times minus 5 over 3 times minus 8 over 3. And my apologies, I put x cubed and this should have been 2x all cubed. I'm giving it away. This is 2x all cubed. This is minus 8 over 3. And all of this is being multiplied by 2x to the 4th power divided by 4 factorial, and 4 factorial is 24. So let's go ahead and simplify this. I know it doesn't look pretty, but we'll simplify it, it will. So f of x is actually equal to 1. Now 1 over 3 times 2x is just plus 2 over 3x. So all we need to do is simplify this side now. Now we're going to have 1 over 3 times minus 2 over 3 times 2 squared divided by 2, that's minus 4 over 9. So this is minus 4 over 9x squared. Minus 4 over 9x squared. And let's work out this part now. We have 1 over 3 times minus 2 over 3 times minus 5 over 3 times 2 cubed divided by 6. And that's 40 over 81. So you get plus 40 over 81 x cubed plus 40 over 81 x cubed. Then finally we'll work out this last part now, which is 1 over 3 times minus 2 over 3 times minus 5 over 3 times minus 8 over 3 times 2 raised to the 4th power divided by 24, and that's minus 160 over 243 minus 160 over 243 x to the 4. And that's the final answer. All right, I know it doesn't look pretty, make it too pretty. Let me see if I can not put this 24 so close to the final answer. This is the final answer for f of x. All right, that's the final answer. Now it says, hence approximate f of 0.4 correct to 2 decimal places. Hence approximate f of 0.4 correct to 2 decimal places. So that means f of 0.4 is going to be f of 0.4, we're going to replace x with 0.4. That's going to be f of, putting in 0.4, we're going to get 1 plus 2 over 3 times 0.4 minus 4 over 9 times 0.4 minus 2 over 3 times 0.4 times 4 over 9 times 0.4 squared plus 40 over 81 times 0.4 cubed minus 160 over 243 over 0.4 to the 4. F of 0.4 is equal to, we put in 0.4 now in our calculator, find out what we get, 1 plus 2 over 3 times 0.4 minus 4 over 9 times 0.4 squared plus 40 over 81 times 0.4 cubed minus 160 over 243 times 0.4 raised to the 4th power, and I'm getting 1.21. So I got 1.21. 1.21. That's what I got. Now, just to check if our answer is correct, what I'm going to do is plug in f of 0.4 here just to check if we're good. So this is just a check to see if the two answers are close. If they're close, then I know we didn't make any error. It's good to do a check. So you do a check and you find out what is f of 0.4 around here. F of 0.4 is going to be equal to, doing the check around here, it's going to be 1 plus 2 times 0.4 2 times 0.4, and all of this is raised to the 1/3. So this is just a check. So you do this check to see what you get, which is 1 plus 2 times 0.4, and you raise this to the 1/3. I get 1.22. So now I notice that I get 1.22, and this is pretty much close right here. So I know we didn't make any mistake. So Gucci and we're nice, soft. We may continue. All right, now part B. Part B says h of x is defined as x cubed plus x minus 1 and is defined on the interval 0, 1. Show that h of x has a root on this interval. So first thing, we'll start by finding h of 0. And we'll find h of 0, which is equal to h of 0 is equal to, plugging in 0, we get minus 1, which is less than 0. And then we plug in h of 1. Plugging in h of 1, we're going to get, plugging in 1, we get 1 cubed plus 1, which is 2. 2 minus 1 is 1, which is greater than 0. So what that means, guys, this is a cubic function. All right, so what that means is a cubic function, and we're focusing on this interval. So we have some interval, right? This is all, well, let's do a better sketch. So this is the interval that we have, right? So this would be h of 0. H of 0 is minus 1. And this is h of 1. H of 1 is 1, right? So by IVT, there must exist some root that is between 0 and 1. That's all the IVT says. Because h of x is continuous, and h of 0 is negative 1, and h of 1 is 1, there must exist some root. This root right here, we can call it c, where c is an element of 0, 1. That's IVT. So let's write that down now. So let's conclude now. So since h of x is a continuous function on the interval, since h of x is a continuous function on the interval 0, 1, and h of 0 and h of 0 is less than, h of 0 is negative, and h of 1 is positive. Hence, by intermediate value theorem, h of x, let me not squinch it up like that. By intermediate value theorem, h of x has a root c. You can say it has a root c that lies on the interval 0, 1. So that's the intermediate value theorem. All right, nice and easy, solved. Let's continue with this question now. It says, use the iteration of xn plus 1, which is equal to xn squared plus 1, with estimate x1 being 0.7 to find the root of h correct to 2 decimal places. Let's tackle this easy question. It says, use the iteration of this formula to estimate the root correct to 2 decimal places. So we're going to say, using this iteration, x2 is equal to 1 over x1 squared. All right, I don't know why this keeps happening. All right, let's continue. Don't know why that keep happening. So it's going to be 1 over x1 squared plus 1. That's going to be x2, which is equal to 1 over 0.7, 1 over 0.7 squared plus 1. 1 over 0.7 squared plus 1. That is going to be equal, so we need to work this out. 0.7 squared plus 1. And so we're getting 1 divided by that is 0.671. So this works out to be 0.671 0.671. Nice and easy, soft. So that's what we get, 0.671. All right, no issues. So it says use 2 iterations of the Newton-Raphson method with initial estimate x1 to approximate the root of the equation g of x being e to the 4x minus 3 minus 4 in the interval 1, 2. Give your answer correct to 3 decimal places. Now the key thing is that, look what it said right here, use 2 iterations, meaning we're going to do it twice, right? So first thing, before I even attempt the question, I am going to find the derivative, all right? So g of x is equal to e to the 4x minus 3 minus 4. And so I need to find the derivative, which is g prime of x. And so g prime of x will be equal to g prime of x. I differentiate this to get 4e to the 4x minus 3. That will be g prime of x, right? And so all I need to do now is find out what is g of 1. Using Newton-Raphson formula, we know that x2 is going to be equal to x1 minus g of x1 over g prime of x1. That's Newton-Raphson formula, g prime of x1. All right, nice and easy. And this is for the first iteration. All right, this is first iteration. All right, so let's go ahead and work this out. So using the first iteration, it's going to be x1 is 1. So it's 1 minus, find out what is g of x1. G of x1 is, put in 1 right here. 4 times 1 is 4. 4 minus 3 is 1. So that's going to be e to the 1 minus 4 over g prime of x1. Put in x as 1, you're going to get 4 minus 1 is 1. And so that's 4 times e to the 1. So that's 4e. Work out what all of this is in a calculator. So you have e minus 4 divided by 4e. Then you have 1 minus the answer is 1.11. So I get 1.118, correct the 3 decimal places. And then I need the second iteration. So the second iteration will be x3. All right, so the second iteration will be x3, and so x3 will be equal to 1.118 minus g of x1. In this case, it's going to be g of 1.118 over g prime of 1.118. So we're going to work out all of this now. We're going to work it out, no issues. So we're going to work it out and get that x3 is 1.18 minus g of 1.118. Put in that now, it's going to be 4 times 1.118 minus 3. And we have e raised to that minus 4. That's 0.357. This part works out to be 0.0357 divided by g prime of 1.118. So go up here, now I'm putting x as that. So it's 4 times e raised to the 4 times 1.118 minus 3. 4 times that. Let me do that again. 4 times 1.118 minus 3 e raised to that minus 4. Why is it not giving? It's giving me math error. Let me go one more time. 4 times 1.118 minus 3 e raised to that times 4. That's 17.43. Come on, man, calculator. Why you want to fail me? 17.43. So you work this out and you're getting the next approximation is, your final answer is minus 0.357 divided by 17.43. And when you add that to 1.118, you get 1.1179, which is the same thing. 1.118. So that's the final answer. Nice and easy. 1.118. Nice, soft. That takes care of this question.